This last section we're looking at the present value of an annuity. It's a little stranger calculation because, as you will see, the present value of an annuity is more of a useful number than it is an actual dollar amount. And so let me show you the idea. Here's one situation where someone has an annuity, then they're putting $50 a month in, and we will know how much they will have in 5 years. Using the annuity formula, this is what we come up with. In the other situation, this other person deposits this much money today. It's not an annuity, it is just a compound interest problem. So compound interest formula gives the same amount of money. Now, I've designed these numbers just to illustrate what's going on and what the present value of an annuity means. Notice both of these accounts have the same interest rate, same amount of time. One of them we're making deposits into an account every month. The other one is just a lump sum of money in the beginning, and they both amount to the same thing later on. And so the $2,714.95 is referred to as the present value of the annuity. That sum of money today is the same thing as the $50 a month for the next 5 years. And so the idea, let me show you just some of the things that present value allows us to do. You can see in the descriptions here that anything dealing with loans and loan payments, like car loans, house loans, any kind of loan where you're making a monthly payment, these are figured using the present value formula. Present value formula, notice, looks a lot like the future value formula. Let me point out two differences. Notice the position of the 1. It comes first in the top instead of at the end. And also, notice the exponent has a negative sign on it. Here's an example of how we would go about using the present value formula. So here's a person that has a loan. They're making $695 a month payments on their loan. The APR, stands for annual percentage rate, is a term or an acronym that simply means we're compounding monthly. However, we want to know what is the amount that she owes with 10 years remaining on her loan. The idea here is the amount she owes is the present value of those remaining payments. And so, using the present value formula, substituting the values for payment and interest rate and method of compounding and time. Now, the time is the years remaining. The T is 10 years remaining. We don't even know in this example how many years her loan was for or how many years she has actually paid on the loan. But the unpaid balance is the years remaining. So doing this calculation, we've done this before, appropriate parentheses, typing it properly on the calculator, here's what we get. Now let me show you another one. This one is asking for the monthly payments on a car loan. The way we look at this is the $20,000 that we borrowed, which we actually never saw because it was all done, we got the car, somebody else got the $20,000. The $20,000 is the present value of those future payments. And so to find the payments on a loan, we use the present value formula, substituting all the values in except for the PMT, and then solve for the PMT. Well, we need to do this calculation on our calculator with appropriate parentheses. Now, to make it handy for calculating. We can store that number rather than retyping it, and then divide 20,000 by that. Finally, notice on this one, it is also an annuity, because it says annuity in the first sentence. And the question is, how long can Bob make withdrawals? The 500,000 is the present value of those future payments. And so the idea is to use the present value formula and substitute everything in. Now this is much like what we did with the future value formula. We want to divide out the 4,000. We want to take these quantities and replace them with letters. You can do this with numbers, but I think you'll find it easier to deal with if you'll learn to use the letters. Here's what it looks like now with the letters. We need to multiply by the K, rearrange terms, move the IK to the right, move the J to the negative 12T to the left, and change to logarithms. Number 1, what's the base? J. Number 2, the logarithm is the exponent. That's the negative 12T. And then the other number is the 1 minus IK. And again, we can type that as a single thing on a TI-84 with the new operating system, or as two different logarithms. And then divide by the negative 12.